All right. So here we go. All right, all right, all right. Welcome on in, everyone, to this live. I am Robert, the AP Math Guy, and tonight we're going to be starting our first set of derivative rules, which are going to be power rule, product rule, and quotient rule. So as you join in, I'll start waving to people for a few moments. So welcome on in, everyone. Hopefully everyone's enjoying their Friday night. And you might be noticing at the top of your screens, there's a little, a little tracker here on the top of your screen. So, as I said before, my goal at the end was that by the end of the year, I would hit 1,000 followers here on TikTok, and I think that that's going to happen much sooner than the end of the year. In fact, I believe that it could happen tonight. So as you can see, we are 96.5% of the way. Yeah. So hopefully we can get that to happen tonight. So welcome on in, everyone. And in case I can't actually wave at you by clicking the button, I'm gonna wave at you now. Hi, everyone. And again, welcome on in. As you're joining in, go ahead and hit that like button. And we'll get started with some calculus for this evening. And again, I'm just going to spend the next couple minutes going through the chat, waving at everyone that I can. And in a couple minutes, we'll go ahead and get started. And I apologize if I miss anybody. But yeah, how is everyone doing on this Friday evening? I mean, I'm doing pretty well considering it's 11:30 at night over here on East. But yeah. So let's go ahead and get started. So, last night, as you may or may not remember, we talked about this idea of the limit definition of the derivative. And what is the limit definition of a derivative? Well, remember that the limit definition of a derivative says that if I have a limit as is basically the limit as h goes to 0 of our slope. So remember that this is the slope of a tangent line of a function. So remember that we had that our tangent line is essentially the slope of the secant line, but where we touch at one point. So x plus h is x is our starting point, and x plus h is our starting point plus a tiny offset. So essentially, we had, remember our slope is f of x plus h minus f of x all over x plus h minus x. Well, as we can see, x minus x, we can say bye to that. So we had left f of x plus h minus f of x all over h. This is the slope of our tangent line. Do you teach College Calc 1? Yes, I do. I do indeed. In fact, that is what I am doing right now. So let me say hi to a few of you who are in here as you are joining in, and I apologize for not seeing you sooner. What is f prime of x? F prime of x is going to be our derivative. So we're going to see that a few times tonight. That is a good question, Asuda. So yeah. And then, because I want to find my so eventually I want to get my 2 points so close together that h is essentially 0. So that is where this comes in. This limit as h approaches 0. So we want h to get really, really close to 0. But remember, even in calculus, we still cannot divide by 0. So we can only get very close to 0. What is a derivative? The derivative tells the story of the slope. So derivative is the derivative basically x for limits? Nope. So the derivative is essentially the slope of the tangent line at a point. Thank you, Oso, for the follow. Thank you, Tanya, for the follow. And as I'm sure you can see, there is a bar at the top of your screen that tells you how many followers I have and how many follow. And so my goal for the end of this year was to get to 1,000 followers by the end of the year. But it looks like I'm going to get there a lot sooner. And to be honest with you, I think it can happen tonight. So that's why I have this little meter at the top. So that way, when we do hit our goal, when I do hit my goal, I'll be able to know immediately and be able to celebrate with you all. Thank you, Augustine Sandoval, for the follow. Please help me with a math problem. I'm desperate. So tonight, I'm going to be focusing on these 3 topics. If you want, if it involves that, feel free to send it to me. Or feel free to type it in the chat. If not, feel free to message me, DM me, and I'll be able to help you there. Can you be my math teacher? Well, I'll be your TikTok math teacher. Unfortunately, I can't physically be your math teacher, but I'll be your TikTok math teacher, Asuda. What rule did I just do? I haven't done a rule yet. All I've done was just recap what we did last night. I just started calculus. Wait, Unc, are you showing the proofs for them or just explaining them? Both. So I'm going to show the proofs for all 3 of these. Yeah, no problem. Real analysis tips currently studying in undergrad. It has been... When was the last time I took real analysis? I think that was 10 years ago. Thank you, Mai, for the follow, and thank you, Christopher, for the follow. What happens if your limit approaches infinity and you take the derivative? So the limit is approaching infinity, but you take the derivative. I'm not quite sure. Can you give me an example of what you're talking about? It's not a limit, it's a discontinuity. Right. So, well, it really depends on the function. L'Hopital? It seems every time, I have to be honest, every time I do a limit, someone says L'Hopital. Well, the thing is about L'Hopital is that it requires a certain, so L'Hopital requires a certain condition to be met in order to be able to do it. If I don't have 0 over 0 or infinity over infinity or any other form of indeterminate form, then I can't use L'Hopital. And actually, I'm not going to actually need to use L'Hopital tonight because it wouldn't make sense. So the only limits I'm going to do are to prove these three rules. Once I do that, then we won't need the limit anymore, at least for these three. So let's go ahead. Is this Algebra 1 or higher? This is Calculus 1. But I think you can do it, Mai. Or Mal. I apologize if I've been pronouncing your name wrong this entire time. For some reason, the last letter of your name looks like an I to me, but the names are so tiny that I can barely see them. Thank you, user, for sharing the live. Our entire class was vigorously proving L'Hopital for infinity over infinity. Okay. Well, like I said, the thing about L'Hopital is that is one of three conditions that have to be met in order for us to use it. And like I said, tonight, just because I have a limit problem doesn't mean that we should automatically use L'Hopital. We have to really think about and be decisive about how we use L'Hopital. But there are times where we do use L'Hopital and it would absolutely save us time. But, like I said, since I'm proving these three rules... Okay, cool. Yeah, so it's fine. Well, I haven't done calc yet, so that's why it looks like a different language. Fair enough. What is L'Hopital? Alright, so here is L'Hopital. So, suppose I have a limit. X approaches a of two functions, f of x over g of x. And this limit results in indeterminate form. So the two major cases that we're going to see are 0 over 0 or infinity over infinity. If this is true, then that limit, so limit as x approaches a of f of x over g of x is going to equal the limit as x approaches a of f prime of x over g prime of x. And f prime and g prime are just other names for derivatives of f and derivatives of g. But we're not going to use this tonight. But yeah, so with that, let's go ahead and start by first proving power rule. So what I'm going to do for these is I'm essentially going to divide this live into three parts. The first part, which I think will be one of the longer parts, is going to be on the power rule only. So what I'm going to do is I'm going to prove a rule, and then we're going to do a few exercises with that rule. And then once I do 4 or 5 examples with the power rule, I'm going to move on to doing the same with the product rule. And then once I'm done the product rule, I'm going to move on to the quotient rule. So that is the plan of action for tonight. So let's go ahead and start with the power rule. So I'm going to give you the rule, And then I'm going to prove, actually, no. Let's do it a little different. I'm not going to show you the rule. Instead, I'm going to prove the rule. So, whenever I have a function, I'm going to use my limit definition of the derivative to take the derivative. So let's call f of x. We're going to call it x to the n. We don't know what n is, but we're going to say n is any number, any real number. Thank you, Albert, for sharing the live. So, how would I go about proving that? Or how would I go about knowing, or how, let's try this one more time. How would I go about showing what the derivative of the power rule is? So, f prime of x is a mystery. So that is our want. So now I'm going to show you by proof what the derivative is. So I'm going to start by taking the limit as h approaches 0. One thing I forgot to mention last night is that some books use delta x for h. Just know, as long as you can say consistent, whether that says h in your book or delta x in your book, it's the same exact thing. I choose to use h because that's how I was taught. I personally don't like the whole delta x, but if your book says delta x, then use delta x. But just know they are the same exact thing. So, remember, the limit definition is right here. So remember, when I have f of x plus h, it means take x plus h and plug it in everywhere you see an x. So I have x plus h all to the n. And then minus f of x. What's f of x? F of x is x to the n. X to the n all over h. Now, in order to continue, I need to show you something. So, how do I know, how do I expand x plus h to the n? Well, there's a pattern. Thank you, Waka, for the follow. Thank you, KSWX77, for the follow. We are 23 followers away. So here, I'm going to show you something to continue. So let's let n equal 2. Oh, sorry. That's not what I want. Let's let n equal 2. So this means x squared minus a squared. So I'm going to pretend that x plus h is, I'm not going to call it x plus h for a moment. I'm going to call it bottle cap. So I have bottle cap to the n minus x to the n. Well, here, this is difference. If I let n equal 2, this is difference of squares. So how do I factor difference of squares? Well, it's xa, xa. One is a minus, the other is a plus. So now, what about cubed? What about x cubed minus a cubed? So I have x cubed minus a cubed. Well, what happens is, again, I have x minus a, and then I'm going to use difference of cubes. So it's x minus a, and then I have x squared plus ax plus a squared. Right, so I use SOAP here. So remember SOAP, same, opposite, always positive. Thank you, Kim, for sharing the live. Oh, wow, we are 21 away. So, this tells me what the signs are when I have sum or difference of cubes. So, my first sign is going to be the same as the sign that's out here. Thank you, bipolar opposites, for the follow. So I have my same sign, and then the next sign is going to be opposite. So whatever I have out here, the next sign is going to be opposite. So here I have a negative, so this second sign is going to be positive. And then my third sign, always positive. So no matter what, this sign over here will always be positive. Hence, SOAP. So now, what do we do with x to the n minus a to the n? Well, what happens here is I still have my x minus a, and now here's where things get a little messy. So here we go. So I'm going to take my first term, my x, and I'm going to subtract 1 from the exponent. So here, like here, when I have difference of cubes, my x term over here is I subtract 1 from the exponent. And I do the same thing here, because remember, a variable without an exponent is the same as x to the first, as it raised to the first. So this is going to be x to the n minus 1. And then what I'm going to do is I'm going to add, and now I'm going to subtract 2 from that exponent. So I have x to the n minus 2, but I'm going to add a to the first. So remember, just like last night when we did Pascal's triangle, subtract 1 from this exponent and add 1 to that exponent. So what happens is that if I continue that, eventually what I get is plus x to the first, a to the n minus 1, or n minus 2, plus a to the n minus 1. Thank you, Jesselyn, and thank you, Aman, and thank you, Angie, for the follows. We are almost there. So, now, this is the complete factoring of x to the n minus a to the n. So, same thing is going to be true with bottle cap to the n minus x to the n. And what's underneath the bottle cap? Well, it's x plus h. So, let's apply this to that. So I'm going to write it down so that way I can follow it along. So here, I have that rule. So I'm going to use that here. So I have limit as h approaches 0 is going to be the following. I'm going to need to have a longer fraction bar to make this work. So 14 to go. Let's go. So I have x plus h minus x. So this is going to be, I'm going to let my x be x plus h and my a be x. So I have x plus h minus x. Thank you, Matilda, for sharing the live. And then I have x to the n minus 1. So this, remember, this is my x. So it's going to be x plus h to the n minus 1 plus x plus h to the n minus 2 times x to the first plus dot 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 plus x to the first time, or x plus h to the first times x to the n minus 2. And I apologize in advance that you won't be able to see this fully. I'm going to go ahead and lift my camera up as soon as I am done writing this. N minus 1 all over h. So let me go ahead and raise my camera as much as I can to try and fit it all in. There we go. So there's a limit over here. Limit as h approaches 0. So here, what do I have now? Other than a blurry screen. Thank you, Andy, for sharing the live. So from here, what do I see? I have x minus x. So we can say bye, bye, bye to those. And also, look, I have h times all of this. So h times all of that divided by h, we can also say bye, bye, bye to those. So now, all I'm left with is this. So limit as h approaches 0 of the following. So this is going to be x plus h to the n minus 1 plus x plus h to the n minus 2 times x to the first plus dot 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 plus x plus h to the first times x to the n minus 2 plus x to the n minus 1. Why is this camera so blurry? Is it just me, or is this camera a little blurry? Or maybe it's on my end. Looks okay? Okay. Yeah, for some, I think I know what the problem was. So my brightness isn't all the way up on my computer. So I think now it's better. Perfect. So now, remember there's a limit here. So now, do I have to worry about division by 0? What is this? This is calculus. No, I don't have to worry about division by 0 anymore. So what I'm going to do is I'm going to plug in 0 everywhere I see an h. So I have x plus 0 to the n minus 1. So that's just going to be x to the n minus 1, right? Because anything plus 0 is itself, plus x plus 0 to the n minus 2. So that's x to the n minus 2 times x to the first plus dot 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 plus x plus 0 to the first is going to be x to the first times x to the n minus 2, and then plus x to the n minus 1. Thank you, FX, for the follow, and thank you, Giselle, for the follow. So here, what do I have? So now I have one more rule that I have to use before I can finish this problem. So remember that x to the m times x to the n is equal to x to the m plus n. Teach me how to code. Unfortunately, I don't know how to code. Believe it or not, I don't know how to code. So here, I'm going to apply that rule everywhere here. Thank you, Sightful, for sharing the live. So I don't need to apply it there. So this is going to be x to the n minus 1. You just learned by times tables what this is. Cool. That is really cool, Land. So now I have x to the n minus 2 times x to the first. So that means I have x to the n minus 2 plus 1. So the n stays where it is. Negative 2 plus 1 gives me negative 1. And what ends up happening is that I have all of these x to the n minus 1s. So from here, I need to figure out how many of these n minus 1s I have. Well, I have as many terms here as I have in my original exponent. So my original exponent is n. So therefore, how many of these do I have? I have n. And that, my friends, is the power rule. So we have just discovered by proof what the power rule is. Miss Math class, love math. I'm glad to hear that, JT. Yes. Oh, that's right, Mark. I can't forget that. QED. If you have this many terms, why not just do the power of rule or FOIL it? I'm not quite sure what you mean. So are you meaning FOIL that? If you mean that, then the answer to that question is I don't know how many times to FOIL it. So n, remember, is any number. So this could be a 2, that could be a 100, or it could be 7,627,968. I don't know about you, but I don't know what x plus h to that large power is. Is this calculus? It is indeed. In fact, we've just proven using the limit definition what the power rule is. So we know now the power rule. And what does the power rule say? The power rule says that if f of x is equal to x to the n, its derivative, or f prime, what I'm going to do is I'm going to take that n and my exponent, move it out front, and subtract 1 from my exponent. What's QED? That's a really good question, Saleda. QED is a Latin phrase, quod erat demonstratum. I think I pronounced that correctly. It's been years since I took Latin. But basically, translated into English, it means that which was to have been proved or proven. OMG, you learned this? That's really cool, Angelica. That is really cool. Yeah, no problem. What's the point of having it there? So if you ever read a mathematical paper, if someone does a proof, this tells you that their proof is done. So whenever you see the words QED next to the end of next to a proof, it means that the proof is done and there's no more to be proven. You got a 5 on your AP Calc BC exam last year. That's awesome. Congratulations. Can you explain the last line? Are you talking about here? Are you talking about this list of x to the n minus 1s? Or this one? Are you talking about the circle, the line I circled, or this line? Or the line right above it? Down here? I want to make sure okay. So this is called the power rule for derivatives. So if we have a function that's x raised to any power, then the derivative, what I do is I take that power, move it out front, and subtract 1 from the power. So we're actually going to do a few examples, a few exercises with this. To further illustrate the point, but we just spent the last little bit just proving that was true. So this is going to be nx to the n minus 1. I need help with a calculus question. How do I send it to you? Feel free to DM me. If it has to do with this, we'll go ahead and work on it tonight. If you take the n in front, why do you still have another n? Are you talking about in the exponent? Okay, so here, I'm not getting rid of this n. So what I do is I take n and I move it out front, but I still keep another n here. It's almost like I'm taking a copy of that n and I'm just moving it out front. But the n's still there. But what I have to do to make up for that copy is I have one less copy of that n in the exponent, so I subtract 1. Oh yeah, calculus so good. I agree. Okay, let's take a look. Let us take a look. All right. Oh, you haven't sent me the problem. Thank you, Solida, for the follow. Thanks, I just finished my pre-calc and taking calc this semester. I'm so nervous. Don't be nervous. How'd you do in pre-calc? Oh, this is delta epsilon. So I'm not going to be doing delta epsilon tonight, but I'll go ahead. I'm actually doing delta epsilon tomorrow. I don't know if this is due to tomorrow, but if not, I'll make sure to save this problem for then. Yo, I'm in the honors pre-calc. Till how long will I see this math? So this is the next level to pre-calc. So once you're done pre-calc, this is next. I'm taking business calculus. What are your studying suggestions? So the difference between... So I did a little bit of research last night on this. So the difference between regular calculus and business calculus, is that business calculus is more application-based. So you're going to see a lot of word problems. So the thing with business calculus is that you'll want to make sure you break down your problems as best as you can and make sure you understand what it's asking. As for studying, so I'm a big fan, no matter if you're taking regular calculus, business calculus, or anything else, as far as any math class is concerned, don't study for too long. So there's something called the law of diminishing returns. So the longer you study, the less you're going to retain. So if you study, say, for 4 hours, odds are you're going to forget more than if you study for like a half hour, take a 10-minute break, study for another half hour, take a 10-minute break. So that way you still study so that way you retain more of the information in less time. Hey man, how do I find the derivative of a tangent line? AP Calc low-key vague. Okay, so the derivative is the slope of the tangent line. So if you're looking for the derivative of the tangent line, you're looking for the slope of that tangent line. And you find that by taking the derivative of the function and then setting that point equal, and then setting the derivative or plugging in the point of interest into the derivative. Right, only 30-minute increments, right. If you want to make it 20, go for it. But I find that 20 to 30 minutes at a time, you're going to retain more by studying less. When do I go live for pre-cal? So I have my regular tutoring students coming back, so I'm trying to figure out their schedules right now. So, but once I do, I'll be able to go live ideally more often. But right now, I'm only going live right now at 11:30 p.m. Eastern. Is this middle school math? Nope, this is Calc 1. What time will I be on live tomorrow? So I will be on at 11:30 p.m. Eastern. Life, it's not enough. You got that right. So now that we know the power rule, let's go ahead and do a few exercises. Also, let's add it to our list of rules. So, derivative rules. That's the proof of the power rule. It shows how the derivative of x to the n comes out to nx to the n minus 1. Right, Grant. That is exactly right. So rule 1, if f of x equals x to the n, then f prime of x is equal to n times x to the n minus 1. Thank you, Grant, for the follow. I think with that, we are 5 or 6 more to go before we hit our goal of 1,000. And I think we can do it. Like I said, I think we can do it tonight. So thank you all for that. So I'm going to go ahead at this point and turn the page. Actually, yeah, I'm going to go ahead and turn the page. That is from last night or the night before. So, example. So, f of x is equal to x to the 5th. Find the derivative of f of x. So that's what this f prime of x means. So this means the first derivative of f of x. So, what I'm going to do is I'm going to apply the rule we just learned. And what's that rule? Well, it's if f of x equals x raised to a power, then f prime of x is going to equal the exponent carried out, take the exponent, move it out front, and then subtract 1 from the exponent. So here, that's right, Ty. So what I'm going to do is I'm going to take this 5 and I'm going to move it out front. So I have 5, x comes along for a ride, and I have 5 minus 1, which is 4. And I promise you, that's it. That is it. Kind of cool, isn't it? I think it is. Thank you, Highborn, for the follow. So you just bring the exponent down in front and subtract 1 from it. Correct. That is absolutely correct, Grant. Power rule, my beloved. Yes. Power rule is probably the easiest derivative we're going to find. Shall we try another? Let's do that. Let us try another. Besides e to the x, yes. Yes, e to the x is also an easy derivative to take. So now, let's try another one. F of x equals x to the 10th. What would the derivative of that be? Go ahead and type in the chat what you think the derivative of x to the 10th is. Fruit Loot says x to the 9th. Clark the Shark says 10x to the 9th. Doll says 10x to the 9th. Ty says 10x to the 9th. Michael says 10x to the ninth. Hefe says 10x to the ninth. For you, Nada says 10x to the ninth. JRA says 10x to the ninth. So it looks like there's an overwhelming consensus that it's 10x to the ninth. So let's see if you're right. So again, I'm going to take my exponent, move it out front. X comes along for the ride. 10 minus 1 is 9. You were really close, Fruit Loop. You just forgot to put the 10 out front. What would you say? On a scale of 1 to 10, how difficult would you say that is? Ty says 0. 4U says 0. JRA says 0. Dull World says 1. Yeah, it's really not that bad. It's not, but that's okay, Fruit. 10 to the 9th. That's okay. DDX of X. Yep. You just learned this in physics? That's really cool, Ryan. That is really cool. So, Fruit Loops intro? Kind of. Alright. I'm going to show you another one, but this time the focus not good on my camera. What if it was a negative power? That's a really good question. Would you like to see? Okay. We'll do, the next one we'll have is going to be a negative one. So let's say f of x is equal to x to the negative third. What do you think the derivative would be? Am I going to do more calc review in the future? Absolutely. Billy's version says 1 over 3x squared. Ty says negative 3x to the negative 4. Ada says negative 3. That boy says negative 4. 4U says negative 3x to the negative 4th. Alex says negative 3x to the negative 4th. Thank you, Buster, for the follow. So it looks like we have a consensus as to what the number out front is going to be, but we don't have a consensus as to what the power is going to be. That's okay, Fruit Loop. That is perfectly fine. Thank you for the honesty. So here's what we're going to do. Ready? I'm going to take this negative 3. I'm going to move it out front, as I did before. And remember, what does the derivative rule say? The derivative rule says subtract 1 from the exponent. So when I subtract 1 from negative 3, it's the same as it's the same as if I were adding 3 plus 1 and then slap a negative sign on it. So negative 3 minus 1. So if you already owe me $3 and then you owe me another $1, that you now owe me $4. But remember, I like to have positive exponents. If you want, go ahead and take a screenshot of it. We are 2 away from 1,000. You're welcome. Why does this so easy but look so hard? That's believe it or not, a lot of calculus. The problems look scary, but when you actually do them, they are actually not that hard at all. They're a lot easier than they look. Thank you, Hycia, for the follow. That's right, Michael. So I'm going to make that a positive exponent. How? Yeah, for some reason, let me try an autofocus. Is that better? And I think there it is. I think we have finally hit our goal. Thank you, Maman, for the follow. Let's see. There it is. There it is. 1,000 followers. Thank you, Geosci, for the follow. And thank you all for joining me here. Thank you for... I keep on saying it, but now that I've hit I finally hit 1,000. I'm gonna stop what we're doing for a moment. And thank you all for helping me achieve this goal of 1,000 follows. Honestly, I didn't think I was gonna get there this fast, but the fact that I didn't, and like I said at the beginning of when I first went on live and when I first joined TikTok, my goal was to try and get 1,000 followers by the end of the year, but it turns out that thanks to you all, I finally hit 1,000 a lot sooner than that. So, thank you all for everything. Thank you for the follows. Thank you for liking the live. Thank you for sharing. Thank you for all the comments in the chat, and thank you again for just being here. Like I said, and I keep saying this, but I really do appreciate you all being so involved in the chat. It's a lot more fun talking to you all and sharing this all with you than it is talking to a brick wall. Because let's face it, talking to the brick wall is not fun. But like I said, I did not think for 5 seconds that I was going to hit this goal this quickly. I thought it was going to take me a while, a lot longer. Like, I was going to be happy if I hit it at the end of the year. But the fact that I've hit it took me... I've been on TikTok now for almost 3 months. And... like that, I'm just at a loss for words right now. I'm just really thankful for you all. I really am. Thank you all for the emojis. Thank you all for your congratulations. Like I said, yeah. Anyway, where was I? Oh, yeah. Thank you, Mr. B, for the follow. Thank you, Fruit Loop, for the follow. Thank you, Trick Sorcery, for the follow. Can the answer be 1 over negative 3x to the 4th? Yep. So that is actually what I was going to do next before I saw that we hit the goal. So here, because I have a negative exponent, remember that x to the negative n is equal to 1 over x to the n. Now, here's the important thing. Only the thing that is being raised to the negative power goes into the denominator. So sometimes you'll see stuff like 3 plus x to the negative n. In this situation, only the x goes down to the denominator. This 3 does not go in the denominator. So what would this be? This would be 3 plus 1 over x to the n. So here, what would this be? This would be negative 3 over x to the 4th. Can I do integration by parts next? So integration by parts, I already have on my list of topics to do, but tomorrow, so it's going to be a little bit before I get there, because tomorrow I'm going to be doing epsilon delta, and then for Sunday I think I'm going to do chain rule next after that. Thank you, Rorchia, for the follow. And I'm sure TikTok has a notification for me to read at some point, and I'll read it at some point. But do you do stats review? I do. I'm trying to find a good time to do it. Thank you, Care Bear, for the follow. Oh, the chain rule. Yes. Yes, the chain rule. The bane of every Calc 1 student everywhere. Do I do differential equations? Yep, I do. In fact, here is a list of everything that I tutor. So at some point, I'm going to get into different stuff like differential equations, Calc 3, linear algebra. I have a few things that I'm going to try and do. I'm going to get into pre-calc, stats. I might even get into some of this stuff, but I know for that, Audrey, ACG Math Tutoring, she's in the chat. She's really good at all three of these. She covers this stuff a lot more often than I do. So if you haven't already, go ahead and give her a follow. She was the one who actually convinced me to join TikTok here in the first place. Thank you, Rice Muncher, for the follow. A junior in high school at my school is taking linear algebra. What is he going to do next? That's actually really impressive. I don't know. It really depends on, because once you get that high, it really depends on what the teacher is talking about, or what the teacher wants to teach. Do I have any flashcards that help? At the moment, no, but I can definitely make some. Basic examples are great for introducing concepts. Hate when they introduce basic rules and complex examples. Yeah, so that's why I try to avoid it. That's why I like to try and do the some basic problems like that, and then once I feel like we're ready, which I think we are now, I'm gonna go ahead and start. What was I going to say? Oh, I'm going to start ramping up the difficulty a little bit. How about rules for calculus? Do you have that? I don't, but it's actually, you know what? You all are giving me great ideas. So, things to make. Calculus flashcards. And calculus rules. Yes, definitely. If I don't write them down, I'm going to forget. And that's not me saying I might forget. No. If I don't write it down, I'm going to probably forget in about 5 minutes. So I'm just going to put them right over here, right next to my computer. Thank you, David, for following the follow. Factoring with negative fraction exponents. That would be interesting. That would be very interesting. I mean, I'm not going to do them tonight, but that sounds really interesting. So let's go ahead and I'm going to go ahead and ramp up the difficulty a little bit. You should create your own courses and you could sell each course. Yo, do you know chi-square problems for science since they are kind of like stats? So chi-squared is actually statistics. So yeah, I do know chi-squared. Yeah, Yeah, so like I said, I can definitely put that on the list of topic requests as well. So I'm going to show you something. This is my topic request list, and as you can see, I have a lot. And actually, I'm kind of doing this tonight, so I'm going to check that off. But I will definitely add that to the list. So chi-squared. You should create your own courses and you could sell each course. It's funny that you mentioned that, Draw, because I'm may or may not be doing that already. Or or should I say I may or may not be in development of some courses already. And I'll leave it at that for now. Let's go ahead and so you're super confused. Okay, Dan, where did I lose you? What questions do you have? You saw Laplace transform Fourier transform 2? Yeah, I can add that. You just got here? No problem. You're here right on time. So I'll add that to the list too. All I ask is that just keep in mind that it might be a little while before I get to some of these topics. So what I'm going to do, as I said, once all my students come back, I'm going to look at times that I think I can go live again. So I'm going to try and aim for 2 lives a day here soon. But again, I want to make sure I get my students scheduled first. You just got here and you're bad? No problem. So right now, we're working on this thing called the power rule. And what the power rule says, Dan, is that if I have x raised to any power, what I can do is I can take this exponent, move it out front, and then subtract 1 from the exponent. Thank you, Orion, for the follow. So that is what we're doing. And if you want, Dan, if you want to take a moment and take a screenshot of that, go ahead. Let me know when you are good. In fact, I'm going to fill this a little bit more. So if you want to wait to take your screenshot until then, that works too. Trig functions too. So trig functions are a bit is there any particular thing with trig functions that you want? Okay. So let's go ahead and ramp up the difficulty a little bit. So let's say instead of just a solitary x, what I'm going to do is I'm going to put a coefficient right in front. So let's say here I have 5x to the 4th. Thank you, Educated Idiot, for sharing the live, and thank you, Shoddy, for the follow. How would I take the derivative of that? Yeah, so here, what I'm going to do, so remember the power rule. The power rule says that if I have x raised to a power, I simply take the exponent, move it out front, and subtract 1 from the exponent. So I have, but when I try to move out this 4, there's already a 5 here. So what I'm going to do is I'm going to take this 4 and I'm going to multiply it by 5. So 5 times 4 is 20. X to the 4 minus 1. 4 minus 1 is 3. Now, here's the thing. I could prove using limit definition that this is the derivative, But I don't know about you, but I think this is a lot faster and a lot easier. What do you think? This? Okay, so this is called, so we have f of x here, and this is called f prime of x. So this little 1 here tells me that I'm taking the first derivative of f. Not quite yet, Jerry. I'll add it to the list, but not quite yet. So then it's actually really good that you asked that question, because I'm going to show you what this is. Chain rule. So we're going to do chain rule on today's Friday. Well, it's Saturday now, but I started this live on Friday. So Saturday is delta epsilon, Sunday is chain rule. So we're going to be doing chain rule on Sunday. But anyway, like that, Dan, it's really good that you it's really good that you asked that, because here's why. So this is really important. So here, if I were asked to take the second derivative, so f prime of x is the first derivative. And then if I want to take if I want to take more derivatives, because I can, what I'm going to do, if I want to take the second derivative, I just add another tally mark up there, or another prime. And I call this f double prime of x. So this is the second derivative. That's right, Obsidian. So if I want to take the second derivative of 5x to the fourth, it would just be 20 times 3 is 60, and 3 minus 1 is 2. And then, if I want to take the third derivative, if I want to signify that I'm taking the third derivative, I put 3 primes there. So that is the third derivative. Third derivative. And then after 3, because I don't want this to get super long, so what happens is after 3, if I want to take the fourth derivative, I put f here, but in parentheses up above, I put the number 4. Because eventually what happens is, if I want to take, if I take, say, the 70th derivative, we're going to have f followed by 70 primes divided a time of x. So it could be that f is here, and x ends up going off the page. So rather than doing that, we just, after 3, we just write the number. Now it would be the fourth derivative. Oh, thank you, Bobel Printing Shop, for the goat. I think you sent that a little while ago, but I apologize for not getting that sooner. How do I find the third derivative? Good question. So what I'm going to do, let's do it for this one. So I'm going to start. So in order to take the third derivative, I have to have the second derivative. And in order to have the second derivative, I need to have the first derivative. And in order to have the first derivative, I need to have the original function. So here's my original function. The first derivative is 20x cubed. So the second derivative is just the derivative of the first derivative. So what is the derivative of 20x cubed? Thank you, Tyler, for the rose. What would be the derivative of 20x cubed? Jerry says 60x squared. Michael says 60x squared. Doll says 60x squared. Hey, by the way, the math font is italics times New Roman. Thank you for that, Nexo. Good, that's actually good to know. Dave says 60x squared. Dan says 60x squared. Right. So it looks like we have come to a consensus. Again, take 3, move it out front. 3 times 20 is 60. X to the 3 minus 1 is 2. That's right, Jerry. That is absolutely right. So now, if I want to find the third derivative, I just take the derivative of the second derivative. That's right, Carter. It would be 120x. Because remember, a variable without an exponent is the same. Why is this so out of focus all of a sudden? I think that's better. Maybe I have to move it down a little bit, but... Anyway, so a variable without an exponent is the same as that variable raised to the first. Why did you do 3 minus 1? Cool. So the reason I did 3 minus 1 is because I'm using this thing called the power rule. And the power rule says that if I have x to the n, I take my exponent, move it out front, and then subtract 1 from that exponent. It's kind of like me saying, okay, I'm taking, I have n number of x's. So what I'm going to do is I'm going to take this n, I'm going to take a copy of that n and move it out front. But now I have 1 less copy in the exponent, so that's where that n minus 1 comes from. Well, kind of, but I like that analogy, so I'm going to stick with it for now. Good analogy? Awesome. Glad to hear that. So actually, I could prove that rule using the limit definition, but what I'm going to do is I'm going to make it generic. So rule 2 says that if f of x equals some number c times another function g of x, then its derivative is going to be c times g prime of x. So number times a function, its derivative is the derivative times c. And c can be any number. Well, except 0. But then 0 would be a trivial point. You can't see? Okay. Can you see it now? Awesome. And then there's another rule that I can prove or I might prove later, but for now, we should do some example like natural log. I actually have natural log saved for another day. Today, we're just focusing on power rule, product rule, and quotient rule. Natural log, like that, it's not that I'm forgetting about natural log. I'm just choosing to wait until another day to do it. So, the other rule that I will give you is the following. Actually, there are 2 more I'll give you. Thank you, Dan, for the follow. So if f of x equals the product or difference of 2 functions, then its derivative, f prime of x, is going to equal the sum or difference of the derivatives. Oh, I hated quotient rule, weird formula. That's okay. We're going to get to that tonight. And I'm actually going to prove it to you. I'm actually going to prove those rules for you. And then, before I do the next one, I'll give you one more rule. If f of x is equal to a constant, then its derivative is going to be 0. As I said, I could prove all 3 of these rules, but for tonight, I figure I'll give you them. Thank you, Jerry, for the follow. Mathematician? I wish. I am not. I'm skilled at math, not that skilled. You have a very strong hate for calculus. I'm sorry for that, Nikolai. Well, hopefully tonight, you'll like calculus just a tiny bit more than when you walked in tonight. Nope, not an engineer. Just a humble math tutor. Prove the fourth rule, please. If I have time, I will. So is math the same as calculus? Calculus is a type of math. Think of math as like the universe, and calculus as a galaxy, as a galaxy. Right, it's a branch of math, but it's not all of math. I think I like the tree analogy better. Math is a tree and calculus is a branch. I think I like that analogy more. Cool. Let me try and refocus that again. Because for some reason, my document camera seems to be not cooperating as much as I'd like it to tonight, but that's okay. Do I teach real analysis? I haven't taken real analysis in 10 years. I'd have to relearn it. Could you go over the fundamental theorem of calculus? I think that is already on my list. Right there. I'm probably not going to go over that tonight, but it's definitely here. So I'm not going to forget about it. Okay, so this is what I'll have to take for HVAC. I'm not ready now. Do I do stats? Yes, I do. Not just stats, but AP stats as well. Yeah, I know, right? And I agree. I could if I wanted to. But I still have a few years of schooling to do that. Thank you, Aaron Chips, for the follow. Truthfully, Calc 1 is hard to understand, but the moment it clicks, absolutely. Thank you, McLoser, for the follow. Thank you, Gamariki, for the... Gamariki, wow. Let's try it again. Thank you, Gamariki, for the follow. Thank you, Antoine Garnett, for the follow. You had a horrible teacher for calculus. I'm really sorry to hear that. I'm really sorry to hear that. It's real, and that's the problem, right? The problem with math is that it really depends on how well of a teacher you have. So if you end up with a teacher that's really bad or really doesn't like the like it, then you're gonna have then that's gonna spread to you. But like I said, my goal in here is to make it so that way you like math just a little bit, at least just a little bit more than when you walked in. Thank you, Looks Max, for the follow. All right. Can I do a problem? Yep. I'm just taking a moment to just take a look at the comments and see what people have to say because. But hey, here's the thing, McLoser. You passed. You passed calculus 2, and there's not a lot of people who can say that. So you know what? Good. I'm glad you passed. I'm really happy that you passed. Thank you, Spookies, for the follow. Yeah, it's cool. The derivative rules were pretty... See? Calculus wasn't all bad. Calculus wasn't all bad. There were some positives to it. Okay, so yes, I will do a couple more of these problems, and then we will move on to part 2. So, let's do another example, but this time, let's use our new rules. So, f of x is equal to negative 2 x squared minus 3x plus 7. And actually, what I might do is this. Let's try moving the camera. There we go. Now we're more in focus. Can everyone see that better now? Way better. Perfect. Yeah, I don't know why, but my camera doesn't like being as high as it can go. So yeah, let's use our new rules to find the derivative of this. Nick Loser says negative 4x minus 3. Jerry says negative 4x minus 3. Thank you, Rorchia. I don't know if you're leaving for the evening or if you're just leaving for a few minutes, but if you're leaving for the night, have a good evening and hope to see you again. Dan says x plus 7. Jack, thank you for the follow. Juan says negative 4x minus 3. So here's what I'm going to do. So now, remember that if I have the sum or difference of 2 or more functions, this can be as many functions as you like, I'm just going to take the derivative of each individually. So here, let's focus on this negative 2x squared for a moment and forget about everything else. So I have negative 2. So what I'm going to do is I'm going to take this 2, move it out front. Negative 2 times 2 gives me negative 4. X to the 2 minus 1. 2 minus 1 gives me 1. So 4 is going to be 4x to the 1. So remember, I can say this as well as 4x. Why? Because remember, a variable without an exponent is the same as that variable raised to the first. So I'm not going to actually write that. And then, now we're done with this one, let's focus on this. So, again, variable without an exponent means this is a 1. So I'm going to take that 1, move it out front. 3 times 1 is, or negative 3 times 1 is 3. And then I have x to the 1 minus 1. 1 minus 1 equals 0. And remember, x to the 0 is equal to 1. So, because I have x to the 0, I have 3 times 1, which is, or negative 3 times 1. Wow, I can't speak tonight. Negative 3 times 1 is just negative 3. And then I have this plus 7. So remember, if we look at rule 4, if I have f of x is equals a constant, then its derivative is going to be 0. So here, the derivative of 7 is 0. Because we agree that 7 is a constant, so its derivative is 0. Because the derivative, what does it do? The derivative tells the story of the slope. So that is our derivative. What does what mean? This saying? Okay, so this is a way that links, this tells us that the derivative, it links derivatives and slopes. In fact, the derivative is the slope of the tangent line. Is the derivative the same as the tangent line? It's the same as the slope of the tangent line. So remember, the tangent line is its own equation, or its own thing, but the derivative is going to give us the slope of that line at any point, because the tangent line touches the function at one place. What math level is this? This is calculus. This hurts my brain. It's too many letters and numbers. That's okay. Remember, remember that your brain is a muscle, and just like any muscle, we don't want to hurt ourselves, but at the same time, we want to work it out so that way it gets stronger. Like when I do bench press, I don't put 500 pounds on either side and try and lift it, because, to be honest, I'm going to end up injuring myself. Yeah, no problem. I'm going to have a couple more on here too anyway. Thank you, Sacred, for the follow. No problem. And like I said, I'm going to have a couple more on here tonight. So if you want, feel free to let me know at the end. I'll give everyone a chance to take a screenshot of the completed card. I don't quit, so I'm just going to keep learning. It's just, okay, yeah, I completely understand. I completely understand, staff. And I'm glad you don't quit. And that you keep learning, because that's how we grow the muscle that is our brain. Because I'll tell you what, even I struggled with calculus when I first learned it. But the thing is, after practice and after working with this, it helped me get better and better at it. Absolutely. That is absolutely right, Sacred. So, we're already an hour and a half into this live. Let's go. It does not feel like that. Didn't we all struggle with Calc 1? Absolutely. Say for the negative for save a power was 3. Would the negative still be there? Like here? Okay, so would the negative still be there? Yep. So remember that I'm multiplying the exponent by my coefficient. So a negative times a positive gives me a negative. That should be a negative. And it is a negative, but my pen smudged a little bit. So I apologize for that, but like that, my pen smudged, but that is a negative. How do you find the derivative at a certain point using those rules? Okay, that's a really good question. And I'm glad you asked that, because I'm going to get into that one next. That's actually where I was heading with the last problem of power rule before we move on. You guys took Calc 1 in college freshman year? Yep, I did, but I also took AP Calculus my senior year of high school. So what's like the biggest function? Is there such a thing? No, the rules say that any number I pick, I can always make it bigger by adding 1. So I don't think there's such a thing as a quote-unquote biggest function. Senior year, you took pre-cal. I took pre-calc my junior year. So what happened was I took Algebra 1 at my freshman year, and then so that was actually, I tested out of Algebra 1. So I moved on to Algebra 2 the second semester of my freshman year. So my high school did it really funky. So what happened was what I did, so they had us take 5 years worth of math in 4 years. So to accomplish that, they took Algebra 2 and Geometry, and they made them a semester long, but you had the class every day versus every other day with every other math class. Anyway, so what happened was you would take, say, Algebra 1 first semester and then Geometry second semester, or vice versa, but you would take both classes your sophomore year. And then we had this thing called Algebra 3, which I'm still trying to figure out what it is. But I basically tell people it's the second half of Algebra 2. And then so I took Geometry and Algebra 3 my sophomore year. And then I took Pre-Calc my junior year and AP Calculus my senior year. Bruh, I wish I understood math at your level. Trust me, Ricky, it took me a long time and a lot of practice to get to this point. Right now I'm in differential equations. I don't know if it's a professor, but this is the most believe it or not, McLoser, for me, differential equations was the hardest math class I've ever taken. I actually almost failed differential equations. And I took it my sophomore year of college because my college was small. So we took Calc 1 and Calc 2 my freshman year. And then we had a rotating schedule of 6 classes. What, really? You weren't always this good at math? Nope, I wasn't always this good. I failed the AP exam. Thank you, Ethan, for the follow. But yeah, I failed the AP exam, and so I had to take it again in college. You have a test next week. Can you go over integrals by parts with improper integrals? I can add it to the list. I can't necessarily guarantee that I'm going to go over it, but I'll add it to the list. Or should I say, I can't necessarily guarantee I'll go over it this week, but I will add it there. Improper integrals. My main issue is geometry. How do you prove that? So I find that people, when it comes to math, are in one of two camps. They're either algebra thinkers or geometry thinkers. I'm one of the people who is an algebra thinker. So what I did to survive good job. Let's try that again. What I did to survive geometry was that I thought of it algebraically. Because area of shapes is just a formula. Pythagorean theorem is just a formula. And when you get into calculus, you're not going to have to do prove that this is an isosceles triangle, or prove that this triangle and this triangle are congruent. Am I doing functions right now? Nope. What I'm doing right now is power, product, and quotient rule. When will I know to use product and quotient rule? That's actually a good question, because I'm gonna get to get to those in just a moment. It's crazy how good I did in AB last year in high school, even with subpar geometry skills. Yeah, because the thing about AB calculus is that a lot of it is how well do you remember your algebra, and how well do you remember your trig. Is geometry important? Sure. But that's right. So product means multiplication and quotient is division. So if I multiply two functions together, I'm going to use product rule. And if I'm dividing two functions together, then I'm going to use quotient rule. But like that, I'm going to get to those in just a moment. I have one more power rule question, and then we're going to move on to product rule. And for that, I know I'm going to need a new page. So, let's go ahead and move on to our next one. So I was going through while I'm writing this, I was going through my lives, and I saw that last night's live was my longest. I think tonight's gonna break that. So if f of x is equal to 2x cubed minus 7x squared plus 8x, find the slope of the tangent line at x equals 4. You were on past 2 a.m. last night, weren't you? Yep. And it looks like that's going to be the case again tonight. But that's okay. OMG, this is exactly like one of my homework questions. Cool. So I'm going to show you how to do a problem like that. So here, if I see slope of a tangent line, my mind automatically goes to derivatives. Why? Because the derivative tells the story of the slope. Do I just spawn these problems? Yeah. So for these tonight, I'm just coming up with them off the top of my head. Sometimes I'll use source material like something in my books or a problem online that I think is really interesting. But for problems like these, and the problems you're going to see tonight, I'm mostly going to just come up with them off the top of my head. Thank you, Melly, for the follow. So, slope of a tangent line tells me derivative. So what I'm going to do is I'm going to first start by taking the derivative of f of x. What is the derivative? Almost all. Remember, that's x squared. Oh, I'm going to move this over in case. There we go. I forget that if I have it at the edge of the edge of my screen, sometimes people can't see it. IDK says 6x squared minus 14x plus 8. Nyala says 6x squared minus 7x minus 8. Dollworld says 6x squared minus 14x. Gloria says 6x squared minus 14x plus 8. Michael says 6x squared minus 14x plus 8. The derivative of a constant is always 0, correct? That is absolutely right, but there's no constant here. Sacred said 6x squared minus 14x. Yeah, no problem, Nick. No problem at all. There we go. So yeah, what I'm going to do, I take my exponent, multiply it by my coefficient, so 2 times 3 is 6. And then I subtract 1 from my exponent, so 3 minus 1 is 2. And then I take my 2, multiply by my negative 7. So negative 7 times 2 is negative 14. And then I have x to the 2 minus 1, which is 1. So remember, a variable without an exponent is the same as variable raised to the first. And then, as I say that, remember, variable without an exponent is the same as variable raised to the first. So I have 1 times 8, which is 8 to the times x to the 1 minus 1. Let me write that 8 a little better. There we go. Well, remember, 1 minus 1 is 0, and x to the 0 is 1, so therefore I'm just going to leave it as 8. But it's not asking for the derivative, it's asking for the slope of a tangent line at this point. So what I'm going to do now is derivative tells the story of the slope, which means I have the derivative. Now I'm going to plug in 4. So I have f prime of 4 is equal to 6 times 4 squared minus 14 times 4 plus 8. What will that give me? What will that give me? Michael says 48. I'm actually going to work this one out because I want to make sure that I have it right. Plug in calculator. If you want to. Love, Care, Respect says 48. Yeah, so let's see if you're right. So 4 squared is 16. 16 times 6 is 96. 14 times 4 is negative 50, 14 times 4 rather is 50, negative 56 plus 8. 96 minus 56 is 40, and 40 plus 8 is 48. And that is our answer. So yeah, that's absolutely right. You worked it out? Awesome, doll. Awesome. So yeah, so before I move on to the product rule, are there any questions on power rule? You're welcome. TikTok just evaluates it when you type it. I actually didn't know that. What will second derivative give? Well, let's see. So if I plug in, if I want to find the second derivative, I'm going to do the same thing as the first derivative. So f double prime. 2 times 6 is 12. X at 2 minus 1 is 1, so that's 1. And then 14, negative 14 times 1 is negative 14. X at 1 minus 1 is 0, so that would be my second derivative. And then we could do this as long as we... So eventually, if you notice, we're eventually going to get to the point where I have the derivative equal to 0. Where I have a derivative equal to 0. Once you hit 0, stop taking the derivative because you can no longer take... Well, you could take the derivative, but it's just going to keep being 0. So I tell my students, if you ever run into a problem where you're asked to take multiple derivatives and one of those derivatives is going to equal 0, you stop there. Like, let's say the fifth... This is how many derivatives is it going to take to get to 0? Third derivative of that is 12. Fourth derivative is 0. So after the fourth derivative, just stop taking the derivative. Right, exactly. For power rule, you can take as many derivatives as the highest exponent plus 1. You are stuck on a problem like this today? Well, here is how you would solve a problem like that. If you want, go ahead and take a screenshot of that. Actually, let me do that first and then take a screenshot. For what value of x tangent will be max? So, max and mins occur when, what will be the highest slope? A critical point should be able to give you that. So we're looking to maximize the slope. That's a good question. I'll have to look into that. But anyway, are there any other questions on power rule before we get to product rule? Tangent also gives velocity. That's right. First derivative, so original function is position. First derivative is velocity. Second derivative is acceleration. Thank you for the follow. Unfortunately, I don't know how to pronounce that name, so... But yeah, thank you for the follow. So now I'm going to go ahead and turn the page, and we're going to go ahead and prove product rule. You didn't know about it, velocity and acceleration. Okay. Product rule. So this is next. So what I'm going to do, just like for the power rule, I'm going to go ahead and start with a proof of the power rule, of the product rule, using the limit definition, and then we'll go ahead and do a couple exercises with the product rule. So let's go ahead and get started. So I'm going to label what calculo is this. This is calculus 1. So I'm going to have f of x. And I'm going to label this as the following. I'm going to call it g of x times, I don't want to confuse you with h. So I'm going to use j of x. And I'm going to prove the product rule. I'm not going to give it to you, but instead we're going to see what it is. So remember, the limit definition of a derivative is what we're going to use to prove this. So let's go ahead and get started. So, limit as h approaches 0 of the following. So remember, f of x plus h means everywhere there's an x in the function, I replace it with x plus h. So this is going to be g of x plus h times j of x plus h minus g of x times j of x all over h. So from here, what I'm going to do is I'm going to go ahead and I'm going to add and subtract something from this. So by doing that, I'm not actually changing its value, but what I'm going to do is I'm going to add or subtract something so that way I can do some fact or something that might help us later. And here, what am I going to add and subtract? Well, I'm going to go ahead. I just have to check my notes quickly. I want to make sure I get this right. Because if I don't, I'm going to mess up the proof, and I really don't want to do that. Here it is. So, what I'm going to do is I'm going to go ahead and add and subtract. Yeah, I was right. So what I'm going to do is I'm going to add and subtract g of x plus h times j of x. So, what is going to go here? So this is going to be g of x plus h times j of x plus h. And then I'm going to add g of x plus h times j of x. And I'm going to subtract the same thing. So this is g of x plus h times j of x. And finally, minus g of x times j of x all over h. You commented an equation you needed help on earlier today. Do you think you could help me understand it? I'd have to go back into my comments to see it. Yeah, so this is a longer one. Can you see it now? No? How about now? What math is this? This is calculus. Cuts limit at end. Okay. I don't necessarily care about the limit right this second. Can you see it now? Well, I do care about the limit, but I don't care about necessarily seeing it. I care more about seeing this for a second. You're learning limits right now in business calculus? That's cool. Awesome. So now, from here, what I'm going to do is I'm going to do the following. I'm going to go ahead and I'm going to factor out a g of x plus h from this side. And then from here, I'm going to factor out a j of x. Is this a problem or a rule, lol? So what I'm doing is I'm proving the rule. Why are you explaining what a derivative is? Khan Academy already does this. Yeah, they do. I just want to be, I'm doing it because I want to. Is this difference quotient? So it's kind of difference quotient, yeah. It's an application of it. So now, from here, what do I do from here? Well, from here, what I am going to do is I'm going to go ahead, I'm going to go ahead and factor out g of x plus h here, and a j of x from those last two. So I'm going to go ahead and do that now. So I have limit as h approaches 0 of g. This is going to make it a little easier to see. G of x plus h times j of x plus h plus j of x, j of x. And then here, I'm going to factor out a j of x. Thank you, Ramashin, for the follow. So then I'm going to factor out a negative j of x, negative j of x, and I'm left with g of x plus h plus g of x. And that's going to be all over h. So now I'll include the limit back. So then, from here, what I can actually do is I'm going to go ahead and split these two limits into two. So remember that if I'm subtracting two things over the same denominator, I can split this into two fractions. And then from there, because I can split that into two fractions, I can split this into two different limits. So I have limit, and actually I want to flip this sign and this sign. Limit as h approaches 0. Actually, I messed up. Thank you, David, for the follow. So what I actually wanted to do was I wanted to flip these. But that's okay, we'll make it work. So I'll go backwards a step. And what I'm going to do instead is I'm going to move this over here and this over here. So I have limit as h approaches 0 of g of x plus h times j of x minus g of x, j of x, plus g of x plus h. There we go. Yep. Here we go. Sorry about that. Minus g of x plus h, j of x, all over h. Here we go. Now it's going to work. So now from here, I'm going to go ahead, out of this term, I'm going to factor out a j of x, and out of these two terms, I'm going to factor out a g of x plus h. So again, limit as h approaches 0 of the following. So I have j of x times g of x plus h minus g of x all over h plus the limit as h approaches 0 of g of x plus h times j of x plus h minus j of x all over h. So now I can treat these as two separate limits. So what I'm going to do is I'm going to take this j of x, because I'm essentially multiplying it by this, and because there's no h in it, we can treat it kind of as a constant, so I'm going to move it outside. So I have j of x times the limit as h approaches 0 of g of x plus h minus g of x all over h plus, well, what happens if I plug in, so here again I can multiply these two, so this is the same as g of x plus h times j of x plus h minus j of x over h. So this is going to be the limit as h approaches 0 of g of x plus h times the limit as h approaches 0 of j of x plus h minus j of x all over h. So now, j of x here, do we recognize what this is? Well, that is just the limit definition of the derivative. Although instead of f, it's g. So this is g prime. So this is j of x times g prime of x. And then plus, well, if I plug in 0 for h, I get g of x plus 0, which is g of x. And then here, well, this is just the limit definition again, but instead of g of x, it's now j of x. So this is going to be j prime of x. And that is the product rule. So this is g prime times j of x plus j prime g of x. And that's it. That is product rule. So now we're going to go ahead and add it to our list. Thank you, Zen, for the follow. So now if f of x equals g of x times j of x, then f prime is going to equal g prime j plus j prime g. Cool. So, let's see. I realize that it's been a minute since I've read the comments. Thank you for the 10K likes, everyone. So I'll just take a moment and see the comments. So where did I... Can you do some factors of factoring with trinomials for tips and tricks? Yeah, I can add factoring to the list. I'm not going to go over it tonight, but yeah, I can do that. This where I start getting confused when stuff starts gets messy. Yeah, so don't worry about this. I'm just doing this to show what the derivative rule is. Don't worry about this, just worry about the rule. Exactly. Derivative goes to 0. Yeah, the limit, so in order to use the limit definition, h has to go to 0. Yeah, but also in some of my homework where cosine and sine start to appear more, I feel like stuff appears out of nowhere. Okay, yeah. So we'll get to sine and cosine, I think, early next week. I start calculus next week. Can't wait. Awesome. That's really cool. Good luck. I know you can do it. Hold on, bud. I'm still in pre-cal. That's okay. This is calculus 1. They're not there. They not there. Okay. I hate limits, lol. I found that derivatives make more sense. Yeah. Well, it's important for us to understand limits in order to get to the derivatives. Ah, yes, the old derivative. I remember the good old days. Yes, indeed. Math skills rock. So cool. Thank you. 1d2 plus 2d1. Okay. Right, exactly. I was taught first function times derivative of second plus second function times derivative of first. Yeah, so remember in addition, order doesn't matter. So whether I start with this and then that, or start with that and this, order doesn't matter. Thank you, Try Bruno, for the follow. So now that we know the rule, let's try a couple exercises. And then we will get to the quotient rule, and then we will call it a night. So, example. Let's say f of x is equal to 4x squared minus 6x, and g of x is equal to 5x minus 2. And I want to find the derivative. Let h of x equal f of x times g of x. Find h prime of x. So what I'm going to do is I have my f and my g of x. So in order to do product rule, remember, I need to find not only the original functions, but their derivatives so I can plug them in here. So let me go ahead. So here's what I'm going to do. I'm going to put f of x here. That was 4x squared minus 6x. And g of x over here. And g of x equals 5x minus 2. What is the derivative of f? What is the derivative of f? Michael says 8x minus 6. Dollworld says 8x minus 6. Yeah. Yeah, that's right. So my derivative here is 8x minus 6. Very good, everyone. What about g of x? Michael says 5. Sacred says 5. Ghetto Out says 1. Dollworld says 1. Gale says 5. Did I say you said 1, Dollworld? I meant you said 5. So yeah, the derivative is 5. Why? Because remember, 5x to the first is 5 times 1 is 5. X to the 1 minus 1 is 0, and x to the 0 is 1. And remember the derivative of negative 2, well, that's a constant, so the derivative is 0. So now I have everything I need to plug into my quotient rule. Yeah, quotient rule. I meant product rule. I think I'm getting a little tired. So now, here we go. Can I do Laplace transforms? Not tonight, but they are on my list. Yeah, I'll do them in time. And like I said, I'm gonna once my tutoring students are settled into their new schedules, what I'm gonna do is I'm gonna start figuring out more times to go live, so that way I can do more subjects. So yeah, live notifications on. Awesome. Yeah, you're welcome, Bruno. I have to admit, I don't know much Spanish, but I know gracias. So yeah. So now, in order to know what I'm multiplying, I'm going to essentially cross multiply. Well, not necessarily called cross multiply, but I think you understand the idea that I'm going with. So here, my 4x squared minus 6x and my 5 are going to go together. And my 8x minus 6 and 5x minus 2 are going to go together. So remember, the product rule says take the derivative of the first function, multiply it by the second function, and then add, and then swap places. So then take the derivative of the second function, multiply by the first, and add together. So here, derivative of the first function is 8x minus 6. 8x minus 6 times my original second function, which is 5x minus 2. And then I'm going to add the derivative of the second function, which is 5, times 4x squared minus 6x. And then from here, I would go ahead and simplify this. So I have h prime of x is equal to, foiling that, I get 8x times 5x is 40x squared. 8x times negative 2 is negative 16x. Minus 6 times 5x is minus 30x. And then negative 6 times negative 2 is positive 12. And then from here, I'm just going to distribute that 5 everywhere. So 5 times 4x squared is plus 20x squared. And then 5 times negative 6x is negative 30x. Wow, this is way easier than how my teacher does it. Yeah. And like I said, when I teach, I like to teach either how I was taught or how I wish I was taught. And the reason why I say how I wish I was taught is some of the things, over the years, I've developed my own way of solving certain problems. Kind of like cheat codes, if you think about it. So I try to share those with you. Because let's face it, your teacher shouldn't be gatekeeping math, so I'm not going to. So here, I'm just going to combine my terms. So I have 40x plus 20x squared, 40x squared plus 20x squared is going to be 60x squared. Negative 16x minus 30x is negative 46x. Minus another 30x is going to be negative 76x. And then plus 12. And that's it. I would stop here. If you wanted to factor something out of here, go for it. I think you could factor out a 4. So what would I be left with? I'd be left with 15x squared minus 19x plus 3. Yeah. So you could factor out a 4, but I'm going to choose to stop there. But yeah. That's it. Are you going to be able to do any examples of sine, cosine, secant, cotangent, square root? I can do some with square root. I'm going to save my trig ones for a later day. I'm probably going to get to those Monday. The h prime, why is the h there, though? Because I just chose it. This could be any letter that's not F or G. If you wanted it to be it to be M of X, you could make it M of X. I just chose for it to be H, just because I could. Because it's the next letter in alphabetical order. Yeah. No problem. Actually, you know what? I'm going to save the square root as well, because that would require this thing called chain rule, which we don't know, which I haven't gone over yet. So here's what I'm thinking. I'll leave the choice for you. Would you like me to go over a quotient rule tonight, or do you want me to save that for Sunday? Because we're going on to almost 2.5 hours. You're tired, go rest, save it. Yeah, I think that's the smart idea. I think that's the smart play. Yeah, I wanted to go over quotient rule, but I'm going to save it for... I think I'm going to save it till Sunday. But... I wonder. One last question. Was this product or quotient? This was product. So yeah, I think it's wise that I save quotient rule for Sunday. So like I said, tomorrow I'm going to be doing, or well, today, because it's technically, for me, because it's technically almost 2 in the morning. So Saturday I'm going to go back to limit for a little bit and finish up with delta epsilon. And then Sunday I will come back and do quotient and chain rule. And then on Monday we're going to do the trig limits. Cool. So yeah, I'm not sure if I want to do a final problem or if I want to call it. Let's do one more. I'll have this be the final problem. Because I think you all are getting tired as well. Can we please do Stokes' theorem? What is Stokes' theorem? Let me look that up. In the physics of electromagnetism, I wouldn't even know where to start on that. Line integral around boundary equals surface integral for a vector field. Yeah, I think I'd have to look that one up. But yeah, we'll do the final problem now, because I did promise at least another one of these product rules. So to get to the final problem, there are 21 of us in here. Let's see if we can't get to 15K. Let's get to 15K likes. And then we will do a final problem. Yeah, like if you have like a line numerator and denominator. Yeah. So that is when we would use quotient rule. So when I'm multiplying, I would use product rule. And when I'm dividing, I would use quotient rule. You missed Calc 1? Yeah. I missed taking Calc 1 too. But it's good that we're relearning it. But yeah, plus I'm kind of excited to see what TikTok has to say about me getting 1,000 followers. But yeah, before we get into the final problem, I just want to thank you all again for helping me get to 1,000 followers. Like I said, I thought I was gonna maybe get to 1,000 by the end of the year. But yeah, like I said, because of all of you, because of all your likes, because of all your shares, because of all your follows, because of all your participation in the chats, you helped me get to 1,000 followers. And again, I thank you so very much for that. And I don't do this without you. So, yeah. You deserve it. Thank you, Christian. Thank you, Doll World. You're most certainly welcome. You know what? I love teaching. I love sharing my knowledge with other people. And I tell people all the time, yeah, I could probably be out in the field of mathematics, discovering the next cutting edge mathematical theory, but my where I find joy is sharing my knowledge of mathematics with people, because in a way, if they go out and they find the next big thing in mathematics, I can say, I helped you get there, and there I can take some of the credit. But in all seriousness, no, I really do enjoy sharing my knowledge with all of you. And like I said, do I make mistakes? Absolutely. To be honest, I probably made a couple tonight, and I'll tell you what, it's not the first time I've made a mistake, and it's not the last mistake that you'll ever see. I love those aha moments, which you get so many from. Thank you, Scooby, for the follow. But yeah, no, like I said, now the real work begins. So I think the next goal, I wonder if I can hit 2K by the end of October. One way to find out. So yeah, I think that's the next goal I have. But I feel like we're gonna get there. I echo the same comments. Thanks for taking time out of your day to teach us. You're welcome, Michael. Yeah, I like that. I enjoy this. This is fun for me. Um, yeah, I like that. I really do enjoy. I really do enjoy sharing my knowledge because who knows? Someone out there might benefit from seeing this, and if I can help that one person go from failing to passing, then mission accomplished. And it's like I say, I would rather. My goal with these lives, and here's the puzzle piece. There we go. Where was I? Oh, yeah. So I, I if this helps someone go from failing to passing or from barely passing to thriving, then I've done my job. And like I say, if after this live you like math, even if it's just a tiny bit more than when you did walking in, then I've done my job. And that's what we're building. That's what I'm building here. My phone died. I was going to ask you if the product rule you're using is ddx equals u times v is u prime plus times v plus v times u prime. Because that, yep. I'm just using different notation. But yes. What your teacher is using and what I'm using is one and the same. I'm just using different notation. I do too, Michael. I do too. We're almost a 15K. I know you all can do it. Can you explain ddx? Sure. So ddx is another way of saying the derivative. So there are these things called so f prime of x and this thing called dy dx. So the way I've heard it explained was these two things are called are nouns, whereas ddx is a verb. So f prime and dy dx says take the derivative of y with respect to x. So if I had y equals something, then dy dx is equal to f prime of x. ddx tells us take the derivative with respect to x. So we're going to see problems later on where we have multiple variables and we're going to be asked to take the derivative with respect to x because we can only take the derivative with respect to one constant until we get to calculus 3 when we do partial derivatives, but don't worry about that right now. Working out math problems is one of your hobbies. Awesome, Michael. Got it. Wow, I finally... You're... No problem, doll. I'm happy to help you. I'm always happy to help. Okay, so I said that as soon as we got to 15,000 likes, we would do a final problem. And here is the final problem. So t of x is equal to 5x cubed plus 7x. And g of x is equal to, let's go with negative 3x. But let f of x equal t of x times g of x. Find f prime of x. I've done good on my quizzes, 90s and higher, but on my test I got a 64 because I didn't finish on time and left some answers blank. I'm sorry to hear that, Gail. Was it because was it be, was it because what was I gonna say? Yeah, so I think with tests, what I usually do is I usually aim for the low hanging fruit first, and then I start with the easier question because of time. Yep, that'll do it. That's okay. Hey, you know what, Elias? Here's the thing. I'm a slow worker when it comes to math too. As you can see, we've been here almost 2.5 hours, and I've only solved like what 6 or 7 problems tonight. But you know what? That's okay. Math is not meant to be rushed. Math is meant to be done at your own pace. It's like doing the crossword puzzle in the New York Times or doing a Sudoku puzzle. No need to rush. And I get it that you're taking a test with a time limit, but I find that rushing to rushing is going to mean more mistakes. So here, what I'm going to do is I'm going to go ahead and name t of x and g of x. So t of x was 5x cubed plus 7x, and g of x was negative 3x. What is the derivative of t? Hey Clinton, how's it going? I'm doing well. How about you? That's right, Sacred. It's 15x squared plus 7. 15x squared plus 7. That's right. And how about g prime of x? Doll says negative 3. Nope, you're right the first time. It would be negative 3. Yeah, exactly. So now, what I'm going to do is I now have everything I need to do the product rule. So I'm going to cross my functions, and I'm gonna, so I know this goes with this and this goes with this. So I have derivative of the first times the second. So this is going to be negative 3x times 15x squared plus 7 plus, I'm going to leave the plus here. Why? Because I have positive times negative, so that's going to be minus 3 times 5x cubed plus 7x. So now, let's simplify. So I'm going to distribute in my negative 3x and my negative 3. So I have f prime of x is equal to, on here I have actually, what would I get here? What would be the result of me distributing that negative 3x into those first two terms? Scared says negative 15x cubed minus 21. Michael says negative 45x cubed. Doll says negative 45x cubed minus 21x. So yeah, let's find out. So here, I have negative 3x times 15x squared. So negative 3x times 15x squared. Negative 3 times 15 is negative 45. And then x times x squared is x cubed. And then negative 3x times 7 is, well, negative 3 times 7 is 21, negative 21. And x times 1 is x. And then, when I distribute in that negative 3, I would get negative 3 times 5x cubed, which is negative 15x cubed. And then negative 3 times 7x is going to be another 21x, negative 21x. So now, final math question of the evening. What does that simplify to? What would this simplify to? Michael says 60x cubed minus 42x. Clinton says negative 60x cubed minus 42x. Doll says negative 60x cubed minus 22x. $42. There you go. So yeah, so negative 45 minus 15 is negative 60x cubed. And negative 21x minus 21x gives me negative 42x. And here is where I would stop. Could you factor out a 6? Yeah, sure, you could. You could factor out a 6x, negative 6x, and you would be left with 10x squared plus 7. And with that, I think we're going to call it a night. Great work, everyone, this evening. Or this morning for me. So, before I go, I'm going to give you my little outro. And then, do we have to factor at the end? It really depends on your teacher. If your teacher wants you to factor, usually we want to factor to simplest terms, but sometimes we either can't or it'll ask us not to. I usually stop here, but sometimes if I want to, I will factor. That's a good question. Okay, so here we go. So you can find me outside of TikTok here. And if you go to this channel, this is my channel over here. When's the next time I go live? I go live every night at 11:30 p.m. Eastern. So I don't know what time it is for you right now, but for me, it is 2:08 in the morning on Saturday morning. So if you do these 5 things, that would be awesome. And then, there are a couple other people. Thank you, Superposition, for the follow. And then there are a couple other people here on TikTok that I highly recommend. So, as I was saying earlier, thank you, Boklet Bip Bookie. That's actually a really cool name. So, anyway, if you're getting ready for your ACT, your ASVAB, your Accuplacer, your GED, your PSAT, or your TEAS tests, or if you simply are looking for help with Algebra 1, 2, or Geometry, I highly recommend ACG Math Tutoring. She's really awesome, and I really think she was, like that earlier, she was the one who convinced me to join this platform in the first place. So, yeah. And then my professor said he was not evaluating my algebra skills, so just, yeah, exactly. On the AP, if you're taking AP, they may want you to simplify if they assume they do. But my professor was the same way. He's like, look, if you get here, that's good enough for me. And then there's also Learning with Lynette. She's really awesome with the abacus. In fact, she's live right now. So as soon as I leave this live, I'm going to go ahead and jump into her live. So go ahead, and if you want to follow me in there, go for it. And give her a follow as well. As well, I offer online math tutoring. So I offer group tutoring, and I also offer one-on-one tutoring. So for group tutoring, I offer this for groups of 3 to 10 students who are all taking the same class. So you don't have to be taking the same with the same teacher or even at the same school. But if, like, let's say you and 3 of your friends are all taking pre-calculus, then you can sign up everyone for group tutoring at the rate of $35 per hour per person. And then I also offer one-on-one tutoring. So normally I charge $100 an hour, but from now until August 31st, if you sign up for weekly tutoring before here, you're going to be locked in at $60 an hour. Once it's 12:01 Eastern time on Monday the 1st, my rates jump back up to here. So if you're interested in either one of these, feel free to DM me and we will set up an appointment for a consultation, which is free, by the way. The consultation is always free. So with that, thank you again for helping me get to 1,000 followers. But the work's not done. The work has only just begun. Thank you, Teach, for everything. Have a good night. You're welcome, Elias. Have a great rest of your evening. W Teacher, I'm taking CalConnect semester following you right now. Thank you. Yes, so with that, have a great rest of your evening, everyone. Or for me, morning. And I will see you all tomorrow at 11:30 Eastern. Bye, everyone.